Hello everyone, welcome to my class. My name is Amara, the physics teacher on Acadastore. Today we're going to be investigating electrostatics. Now all lesson notes are on Acadastore as well as all discussions, the question and answers, the podcasts, assessments and tests, all of them are on Acadastore. Now I'm using PhET simulation to demonstrate this to you. Okay, so I'm going to reset this. Electrostatics are static electricity. We talked about protons, we talked about electrons. In an atom, think of protons as a large, very large stone, and the electrons as small balls. The small balls are the ones that have the tendency to roll around as opposed to the big stone, right? So in an atom, what actually moves around freely is the electrons, not the protons. So when two materials rub together, one has a tendency to lose a higher tendency to lose electrons, while the second one has a higher tendency to gain those electrons. And when an object loses electrons, what is left in that object is a net proton. So the object becomes positively charged. The one that gained the electrons, it means it now has more electrons inside it, right? Then it means that particular material is now negatively charged. So when an object loses electrons, it becomes positively charged because what is left is more, there are now more protons in that object than electrons. While the one that gained the electrons now has more electrons inside it and so because it now has more electrons inside it, it is now negatively charged. So what happens when I rub these three items are neutral because they have equal numbers of protons and electrons in it. So they are neutral. Now if I bring this balloon close to the shirt and rub on it, see what happens. It gained the shirt lost electrons to the balloon. So the balloons now have more electrons. So it means the balloon is now negatively charged while the shirt is now positively charged, right? Now, remember that opposite charges attract while like charges repel. Now you have a plus and a minus, proton and neutron. If I leave this ball and I see there's an attraction, it's attracted to this because this is now positively charged. The shirt is positively charged. The balloon is negatively charged. Now, if I bring the balloon close to the wall, this wall is neutral. But if I bring the balloon close to the wall, it will still attract. But you see what happens? The attraction now, even though the wall is still neutral, the net charge is there is neutral. But it pushed the electrons away because like charges repel. So it pushed the electrons just a little bit away, leaving the protons close to the wall, and that's what made it attractive. Now, let me demonstrate this with two balloons. Okay, let me reset it first and demonstrate with two balloons. Okay, I'm rubbing this here. It has gained electrons. I'm also rubbing this one here. Now it has gained electrons. Now watch what happens when I bring these two balloons together. See, there's a repulsion, right? This second balloon is moving away from the first balloon. If I bring it close to the wall, of course there'll be an attraction. But you see, okay, just watch what happened. The proton and electrons were together. As I brought this closer, it pushed the electrons away because this yellow balloon is negatively charged. It has a net electrons, right? Even though this one is neutral, it now pushes the electrons away, leaving the positive charge at the edge of the wall. So that is why this ball is experiencing attraction. Two of them are experiencing attraction. But if I bring this close here, there's a repulsion, right? It pushes it away because these two balloons are of the same charge. Both of them are negatively charged, so they don't want to be together. So that's one of the basics of when you're talking about electrostatics. You're talking about charges, positively charged and negatively charged, right? And remember that positive like charges repel each other, unlike charges attract each other.